I'm Nathan Greenberg, founder of Ivy League Mentors, and I've been teaching SAT since before many of my viewers were even born. And today I'd like to focus on one of the most challenging question types on the digital SAT. The College Board calls them command of evidence questions, and they ask you to come up with the best evidence to support, or in some cases to undermine. That's SAT speak for go against, a claim in the text. Now, I think a big reason a lot of students struggle with these questions is because they don't have a good approach. So in this video, I'm going to give you 4 simple steps that you can use to solve them quickly, confidently, and best of all, correctly. So if you want to do well with command of evidence questions, the first thing you're going to need is a solid approach. And the approach I'm about to share with you is classroom tested. That means I've used it on hundreds of students, and I've seen it produce great results. But it's also really simple, so I think anyone can learn to master it. Here it is. Step 1, read the question and determine what you'll need to know. Step 2, read the text, focusing on finding the relevant information. Step 3, form your own answer to the question. And step 4...
Mr. Greenberg.
What is it, student me?
That seems like a lot of work. Wouldn't it be easier just to look at the answer choices?
Oh, student me, a classic mistake. So many students jump to the answers without giving themselves a moment to think. Now this may seem efficient, but if you don't know what the correct answer is going to look like, how are you going to recognize it among the answer choices? So it's really important to pause for just a moment and ask yourself, what is the correct answer going to be? And then, once you've done that, you can move on to step number 4. Pick the answer that best matches your prediction. Let's try that together with a relatively straightforward example. So first we're going to read the question and figure out what it is we need to know. Which finding, if true, would most directly support Armijo's hypothesis? Now just looking at the text, I can guess that a lot of the relevant information is going to come in that last sentence because it begins, Armijo hypothesizes that. However, I'm not just going to read that sentence. Instead, I'm going to start from the beginning. And the reason I'm going to do that is because in order to understand that final sentence, there's a good chance I'm going to need to know what comes before it. So let's try that right now. Roasted green chilies are a popular ingredient in Southwestern cuisine, but the traditional method of burning propane is not environmentally friendly. To see if solar power could provide a better alternative, engineer Kenneth Armijo and his team roasted batches of green chilies using between 38 and 42 heliostats, which are devices that concentrate sunlight. The team was successful in reaching the same roasting temperature used in traditional propane roasting, but they found that propane yielded faster results. While the solar roasted green chilies took 6 minutes, batches using propane took only 4. Armijo hypothesizes that they can reduce the roasting time for solar roasted green chilies by using more heliostats. So now that we've read the text, focusing on the relevant information, we should be able to move on to step number 3 and form our own answer to the question. Now again, the question was asking us for information that would support Armijo's hypothesis, and his hypothesis was that having more heliostats can reduce the roasting time for solar roasted green chilies. So, what would support that? Probably some finding that shows that more heliostats led to a faster roasting time. Now, more and faster are relative terms, so we may need to know information that comes earlier in the text. We see before that he used up to 42 heliostats, and so more would be more than 42. And we see that before it took 6 minutes, and so a faster roasting time would be less than 6 minutes. So anything that shows that more than 42 heliostats can lead to a roasting time of less than 4 minutes could be correct answer because it would support the hypothesis. Now that we've made a prediction about what the right answer should be, step 4 should be really easy. Again, all we need to do is to go through our answers and see whether or not they match our prediction. And if they don't match our prediction, we can cross them off. But if they do match our prediction, well, we've probably found the right answer. Let's start with A. The temperature inside the roasting drum is distributed more evenly when roasting green chilies with solar power than with propane. Now this answer clearly does not match our hypothesis because it doesn't tell us anything about the number of heliostats used or how long it took to roast these peppers, so we can definitely cross that one off. We move on to B. Attempts to roast green chilies using 50 heliostats yield results in fewer than 6 minutes. Now this one seems like a very good match. Remember, our prediction was that we're going to show more than 42 heliostats roasting peppers in less than 6 minutes, and that's exactly what our answer tells us. Now, if you're feeling confident, you might just pick answer B, but if you want to double check, you could take a look at answers C and D. And if we do that, we'll see that neither of them are even close to what we've predicted, because neither involve more heliostats leading to a faster roasting time. So in this case, it's pretty straightforward, and in fact, we didn't even really need to read that earlier part about how many heliostats or how much time, because only answer B is related to heliostats, or how much time is needed. Nevertheless, in most cases, the SAT is not going to make it that easy for you, so you're usually going to have to rely on information earlier in the passage to understand the claim or hypothesis that you are supporting or undermining. Let's move on to another example, one that's just a little bit harder. Again, we'll start by reading the question. Which quotation from Loon Point most effectively illustrates the claim? Now, based on this question, it's pretty clear that what we need to know from the text is the claim. So now we're going to move on to the text, focusing on finding and understanding the claim. Loon Point is a 1912 poem by Amy Lowell. In the poem, which represents a nighttime scene on a body of water, Lowell describes an element of nature as an active participant in the experience, writing blank. So now we can move on to the next step, forming our own answer to the question. Now, the claim was that nature is an active participant in the experience, and so we want to look for something that shows nature being an active participant. That means being really involved, actually doing something, almost like a character. And if our answer doesn't show us that, we can cross it off. So let's go through those answers in order. A. Through the water, the moon writes her legends in light on the smooth, wet sand. Now, to me, this seems like it could be a decent answer for our question. Does it involve nature? Well, sure, the moon is part of nature. And is the moon actively doing something? Well, sure, the moon is writing her legend. That's actually personification. It's kind of treating the moon like a character, which is exactly what we predicted the correct answer would be doing.
Mr. Greenberg.
What is it, student me?
Doesn't answer B also portray nature as an active participant? You know, because like the water is rippling. That's doing something.
Well, not really. Yes, there is water, which is part of nature, and the water is doing something. It's rippling. But it's not like the water is actively involved, doing something like a character in the scene, which means that it's not as good as answer A. But this is why this question is a little bit trickier. Sometimes the SAT is going to give you multiple answer choices that look pretty good, and it's up to you to find the best one. And in this case, answer A is the one that most strongly matches our prediction, so that's the one that we should pick, even if other answers sort of, kind of, a little bit match our prediction. Now I think it's time to move on to an even harder example. The next question is one that the College Board rates a 3 out of 3 in terms of difficulty. But if we apply the same 4 steps, we should be able to arrive at the correct answer. So let's try that. Which finding, if true, would most directly support all these people's claim? Based on the question, it's pretty clear that the relevant information in the text is going to be the claim that these people are making. So let's read the passage, focusing on understanding their claim. Mosasaurs were large marine reptiles that lived in the late Cretaceous period, approximately 100 million to 66 million years ago. Selena Suarez, Alberto Perez Huerta, and T. Lynn Harrell Jr. examined oxygen-18 isotopes in mosasaur teeth enamel in order to calculate likely mosasaur body temperatures, and determined that mosasaurs were endothermic. That is, they used internal metabolic processes to maintain a stable body temperature in a variety of ambient textures. Suarez, Perez Huerta, and Harrell claim that endothermy could have enabled mosasaurs to include relatively cold polar waters in their range. So now that we've read the text and hopefully understood the claim, it's time to think about what type of information would support that claim. Now, the claim was that endothermy would have enabled mosasaurs to include relatively cold polar waters in their range. So I would guess that finding mosasaurs in cold polar waters, especially in a way that emphasizes their endothermy, would support that. Let's look at the answer choices and see if we can find something that matches that prediction. A. Mosasaurus likely body temperatures are easier to determine from tooth enamel oxygen-18 isotope data than body temperatures of non-endothermic late Cretaceous marine reptiles are. Now this answer does involve endothermy, but one problem that I see right away is that it doesn't tell us anything about mosasaurs being able to survive in relatively cold polar waters. Therefore, it doesn't seem like great support, and we can cross it off. Answer B. Fossils of both mosasaurs and non-endothermic marine reptiles have been found in roughly equal numbers in regions known to be near the poles during the late Cretaceous, though in lower concentrations than elsewhere. Now this does relate to endothermy, but it doesn't suggest that endothermy would have enabled mosasaurs to live in these cold temperatures. In fact, it suggests that endothermy was not helpful because it says that both mosasaurs and non-endothermic marine reptiles were found in equal numbers in these locations. Therefore, we can safely cross it off and move on to answer C. Several mosasaur fossils have been found in regions known to be near the poles during the late Cretaceous, while relatively few fossils of non-endothermic marine reptiles have been found in these locations. Now here's an answer that looks an awful lot like what we predicted. First of all, it tells us that mosasaurs were present in these cold polar waters. Second, it tells us that there were more mosasaurs in these areas than non-endothermic marine reptiles, suggesting that endothermy probably played a role in this. Therefore, we may want to pick it. But if you still have some doubts, we can move on to C. During the late Cretaceous, seawater temperatures were likely higher throughout mosasaurs' range, including near the poles, than seawater temperatures at those same latitudes today. Now, I can clearly tell that this answer is not as good as the previous one, because it doesn't mention anything about endothermy or non-endotherms. It also seems to go against the idea because rather than emphasizing that mosasaurs could survive in cold waters, it tells us that the waters were actually not that cold. So it seems to go against our statement rather than supporting it. We can clearly cross it off and confirm that C was, in fact, the correct answer. Now that we've gotten that out of the way, I'd like to move on to one final example. This one was also rated a 3 out of 3 in terms of difficulty by the College Board. Now, one of the first things you'll notice about this question is it's got a graph attached to it. A lot of command of evidence questions involve graphs or charts, and when you see this, you may be tempted to jump straight to the graph or chart. But trust me, that is a big waste of time. If you want to solve these questions efficiently, stick to the 4 steps I've given you. So let's try that right now. Which choice most effectively uses data from the graph to illustrate the claim? So the question implies that our correct answer must be true according to the graphic. But again, resist the urge to jump to the graphic now because it's not going to help you, at least at first. And the reason for this is because several or even all of the answers could be true according to the graph. What's going to make the correct answer special is that it will also support the claim. So to identify the correct answer, the first thing we're going to need to know is the claim, and we can read the text with that in mind. High levels of public uncertainty about which economic policies the country will adopt can make planning difficult for businesses. But measures of such uncertainty have not tended to be very detailed. Recently, however, economist Sandil, I'm not even going to try, analyzed trends in news reports to derive measures not only for general economic policy uncertainty, but also for uncertainty related to specific areas of economic policy, like tax or trade policy. One revelation of her work is that a general measure may not fully reflect uncertainty about specific areas of policy, as in the case of the United Kingdom, where general economic policy uncertainty blank. Now, before we move to the answers, let's pause for a second and think about what kind of information would support the claim. This economist found that a general uncertainty measure may not reflect uncertainty about specific areas of policy. So to support this, we want an answer that shows that general economic policy uncertainty was different than policy uncertainty within these specific areas of policy, such as tax or trade policy. Now, with that in mind, we are able to move through the answer choices. And if the answer doesn't support that, we can cross it off. And if the answer does support it, then we can check it against the graph to make sure that it is indeed both supporting the claim and true according to the graphic. A. Aligned closely with uncertainty about tax and public spending policy in 2005, but differed from uncertainty about tax and public spending policy by a large amount in 2009. Now, looking at this answer, it seems not great. The second half does tell us that uncertainty about general economic policy may be different than uncertainty about specific types of economic policy, but the whole first half seems to actually go against it because it suggests that general economic policy can also be similar to uncertainty about specific economic policies. So I feel like it doesn't really say exactly what I want. I'm not sure I can fully cross it off. I might put a question mark next to it, but I'm certainly not going to pick it. And instead, I'm going to move on and see if there's an answer that better matches my predictions. B. Was substantially lower than uncertainty about tax and public spending policy each year from 2005 to 2010. Now here's an answer that does appear to match my prediction because it tells me that general economic policy uncertainty was different, substantially lower than uncertainty about a specific type of spending policy. And because it seems like it could be the correct answer, I'm now going to move on to that next step and check it against the graph. But when I do that, I have a problem. I can see that in fact, general economic uncertainty was not always substantially lower. In fact, in some years, it was even higher than uncertainty about tax and public spending policy, which means that B, although it does support the claim, is not factually true according to the graph, and we can safely cross that one off. C. Reached its highest level between 2005 and 2010 in the same year that uncertainty about trade policy and tax and public spending policy reached their lowest levels. Now again, this one might seem like it could be the answer because it suggests that general policy uncertainty is reaching its highest level at a time when uncertainty about specific types of policy is reaching its lowest, which does imply a difference, just as we predicted. But let's go ahead and check that against the graph. When we look at the graph, we can see that general economic policy uncertainty reached its highest point in 2010. Yet it's certainly not true that both of these other types of policy uncertainty reached their lowest levels in that year. Therefore, it fails to match the graph and support our claim, which means we can cross it off and move on to the final answer choice. D. Was substantially lower than uncertainty about trade policy in 2005 and substantially higher than uncertainty about trade policy in 2010. Now, like answers B and C, we can see that this answer does tend to support our prediction because it emphasizes the idea that uncertainty about general economic policy may be different than uncertainty about specific types of economic policy. But unlike our answers to B and C, it's also supported by the graphic, which means it's a perfect answer. It both supports the claim and it's true according to the graphic. Therefore, we can pick it with confidence. So there you have it. Hopefully these examples have helped illustrate how to use these 4 steps in solving command of evidence questions. I hope you found this video helpful. If you did, please don't forget to like, comment, and subscribe. Thanks as always for watching, and good luck on the test.